Alright, so here's the thing, you guys. You're not just doing Pythagorean theorem anymore, because we're not in middle school anymore. But you're applying it to the other things you know. So here they drew it out for you. On homework, you might have to do this yourself. So we know by definition the rhombus has perpendicular diagonals, and they bisect each other. Okay, we just did those properties in our last unit. And so if it tells us diagonals are 6 and 10, we know each little triangle has sides of 3 and 5. And then, is that one of our triples, or do we have to do the math? We have to do the math. Why do we have to do the math? Yeah, because 3, 4, 5 would be a triple, but 5 would have to be that hypotenuse. And so instead we have to do the math. So 3 squared plus 5 squared equals x squared. What's 9 plus 25? 34 equals x squared. Is 34 simplify or not? No, it goes to 2 and 17, right? So it can't simplify, and so root 34 equals x. Is that what it asked us to find? No. What else do we know about rhombus that will help me find the perimeter?
It's a 90 degree.
All sides are equal, okay? A sad number of students missed that on the test. Where you labeled something rhombus when all sides were not equal. Okay, so all sides are equal, so I just do root 34 plus root 34. And so when we're adding radicals, what do we add? Do we add the 34s, or do we add the invisible one at the beginning of each? Yeah, it's an invisible one. And so this bit just becomes 4 root 34. Or we could take root 34 times 4. Alright, class, remember one talker. I'm hearing some side conversations that shouldn't be happening. Alright, Nadia is really happy on this Monday morning. She is skipping. She's not walking, she's skipping. 3 meters north, 2 meters east, 4 meters north, 3 meters east, and then 1 meter north. Okay? So we're going to draw this. The easiest way is to draw this, okay, as if it was on a map. So north is straight up, right? So 3 north, 2 east, 4 north, 13 meters east. Whoa, that's a lot of skipping. And 1 meter north. How far is Nadia from where she started? Okay, far away. How are we going to find that out? Yeah. And so we're gonna go ahead and draw out a right triangle. Okay, I'm gonna try to find the hypotenuse, which is the direct distance from how far she is. And then how do I find the length of these two sides?
By finding that side.
Yeah, so how far did she go north in total?
7. Oh, 8.
8. How far did she go east in total? So 8, 15, is that one of our triples?
It's 13.
8, 15, 17. See how much time it saves us when we have those triples memorized, okay? And so she is 17 meters from where she started.
That's it?
That's it. See, isn't it great when they give us the triples?
Yeah. So, consider all this.
Alright. What's our next problem about? You guys need to go.
Whose sides have lengths of 10, 30, 10, 20.
Alright. So, boys, focus in. Alright. It told me that the sides are 10, 30, 10, and 20. How do I know which side is which?
is
Yeah.
10. This is 30.
So by definition, I know the two sides have to be the two 10 the same length. And then 20 and then 30. Okay? It wants me to find this altitude. Altitude, by definition, is at a right angle. So to find altitude, I have to figure out what this little part is, right? So then I can do Pythagorean theorem. How can I use this information to find out what this section here is?
No.
Yeah, it's 5, right?
Yeah.
How do we know it's 5?
Because it's 30 on the bottom, and then you take 2, 10, and divide by 2.
Yeah. So 30 minus 20 equals 10. And then we divide it by 2 because there's two sides. So each little side is 5. Is that one of our triples?
5?
5 and then hypotenuse of 10? Nope, we have to do the math. Okay, so a squared plus 5 squared equals 10 squared. So then it equals 75. Do we know what the square root of 75 simplifies to? Five square root 3. And if you need the visual, 75 goes to 3 and 25, which is that perfect square. So when you have that, flip over to our next page. Thank you. Can I turn mine yet?
Yeah.
All right. If this side is 5, what's this side?
Let me check.
5, because they both have those lines.
5, because they both have these lines, okay?
Oh, yeah, that's that line.
That's not a triple. Anytime things are marked congruent, so like if this is 12, this is also 12, this is also 12.
So that's just an equilateral triangle.
This is an equilateral triangle. Okay, so then Pythagorean theorem, 5 squared plus 5 squared equals c squared. What does c equal? 50? So 50 equals c squared. Right, 25 plus 25. Does anyone remember what square root of 50 simplifies to?
5 and 2.
5 and 2. So our answer is 5 root 2. Alright, so on our next one, on our equilateral triangle, what are we going to have to do to find x?
Found the
So we could plug it into one of those. Well, no, it's not a right triangle, so we can't use the altitude formulas from last class. We can use Pythagorean theorem because altitude's always a right angle. So if I'm doing Pythagorean theorem, I'm taking just this half of it. So what's this part? 6, yeah, because altitude's going to be the exact middle. Is that one of our triples?
Yeah.
Sadly, no. Okay, so x squared plus 6 squared equals 12 squared. Can you solve it faster than me? What'd you get?
Calculate that.
Anyone solve it yet?
Yeah, I just told you. Oh, x squared equals square root. Look, I showed
Because
the graphs.
108, and what does 108 simplify to?
9,
9
12.
something else.
9 and 12.
9 and 12?
9 and 12. Just kidding. 9 and 12.
It is 9 times 12, isn't it?
Yeah.
Okay, so 9's one perfect square we can pull out. Does 12 have a perfect square in it?
3.
Yeah, 4 and 3. So there's our other perfect square. So this 9, square root of 9 is 3, square root of 4 is 2. What do we do when we have to multiply them? So it becomes 6 root 3. I did that kind of fast. Dude, are y'all with me on that? Alright, next one. We're going to pause for a minute, see if you can solve that on your own. Or with your group, actually. So plug it in, A, B, C, see how quickly you can get it. So, how many of you all went on to try solving this one?
I'll try right now.
Okay, a couple people. So we're going to go through this step by step. Remember, we're back to one talker. I am our one talker right now. So we just label our A, B, C, and plug it in. So 3 squared plus x plus 1 squared equals x plus 2 squared. So just remember, when we're squaring a binomial, which means we have 2 terms with a plus sign in the middle, we have to actually multiply it all out. So x plus 1 squared is x plus 1 times x plus 1. And we have to do the FOIL or the double distribute, however you learned it. So we get x squared plus 1x plus 1x plus 1. So just remember, we don't just plain have x squared plus 1. We have all terms. Alright, are y'all with me on that step? Okay. So take a minute, stop and look at it. I just did x times x to get x squared. X times 1. 1 times x. 1 times 1. Yeah. Algebra keeps coming back. Okay, same thing when I have x plus 2. I get x squared plus 2x plus 2x plus 4. X is 3. Okay. The really nice thing about this, did anyone find the really nice thing about this? The triple? When we get to it. The nice thing, though, is the x squareds are going to cancel out. When I minus x squared from this side, they cancel each other out, so we are not going to have to factor. So then I just can solve algebraically. So like if I minus 2x and then combine my 9 and my 1. So I have 10 equals 2x plus 4 minus 4. And x equals what? Yeah. So x equals 3. And then, like Matthew pointed out, when you plug that back in, that becomes 3, 4, 5, which is a triple, and we know we did it right. All right. Once you have that, flip over to our last page of notes for this packet. Okay, take a minute, read these 3 definitions, and see if you can tell the person beside you what they mean. Alright, so one of you who said you managed to translate this into English. What is it saying here? Yeah. So if I have a squared plus b squared equals c squared, if I have that Pythagorean theorem, then it's a right triangle, right? But what happens if they aren't equal? What happens if c squared is greater?
Then it's obtuse.
Yeah, so these are just the patterns you need to know. So if c squared is greater, then it's obtuse. Okay? What happens if c squared is less than a and b? Then it's acute. Okay? So it's really simple. You just have to remember c squared is what we judge things by. So if it's equal, it's right. If c squared is greater, it's obtuse. If c squared is less, then it's acute. So, real quickly, we're going to plug these in. Which one is c here? 10, because it's the largest. So 5 squared plus 7 squared, and then 10 squared. What's 5 squared? What's 7 squared? So is 25 plus 49 greater, equal to, or less than 100?
Less than.
Okay, so if 100 is greater,
Then it's c squared is greater.
c squared is greater,
It's obtuse.
obtuse. Okay, and so we're used to writing Pythagorean theorem this way with a squared plus b squared first. Notice that at the top here they always put c squared first just so it's easier to remember the greater than less than. You choose. Do you want to do it this way and then still stop and think, okay, c, or do you want to flip it around?
49. Oh, shoot.
Okay, can you do the next three in your group?
Yeah.
Okay. We're going to take like 2 minutes, see if you can solve those next three. The fourth one should be really, really easy. Okay, so after you get them, check your answers and then go on to page 16 through 17.
Oh, c is greater than